And I just realised I went live, I think. So if you can see me, I realised I am streaming. I'm using the old YouTube, which doesn't give me an option to test my stream. So I'm live. Hello. Apologies because I forget I can't test this before I go. But here I am. Hi, welcome. I am going to be AFK for like 2 seconds, as I've started early, so I will probably bring up something. Oh, that's not the right tool at all, is it? Say, stream will start at 12:00 CST, Chicago. 5 minutes. Let's get that going, and I will be back very shortly as I am making a cup of tea and I'm actually ahead of myself. So apologies about that. Yeah, let me go and get my tea ready. Hi everyone. Hi all. Just getting a cup of tea, then we'll start at midday my time. So 5 minutes, not 10. Well, rather disappointingly, I've forgotten that I'd run out of milk, so I'm having to have black tea, which was not my intention. Let's make sure I can see the chat window there. Two new notifications. Alright, just tweeted to say that I'm sort of starting now, I suppose. Let's close up these things and see if we can use the right window. No, I'm not quite sure why that isn't working. Hello, click. Ah, there we go. Alright. And excuse the extremely loud children opposite. If you can hear them, that is. And I can close that one. So, not only have I started early, I have a substandard cup of tea, which is black. I do like a little bit of milk in my tea. I know it's alien to some. And I was just updating all my various IDEs. So you can see here I'm going to be using C-Line today because I'm going to be programming in C++, which is a rarity for these. In fact, this is a first. I think I have done like a couple of lines of C++ along the way, but nothing special. So as we're getting nearer to where my official start is, I'm sort of just setting up. And I feel like I should explain what I'm doing so that you have some idea about what's going on. But I'll start properly in 3 minutes' time, just to give those who, excuse me, who are going by the original start time of the tweet, the right, the opportunity to start at the beginning. Aha, so here comes Sea Lion. And yeah, I'm going to do the dance of updating the plugins as well. My poor laptop is going to explode. Yes, we'll update that. And because I haven't got any milk in my tea, I had underestimated how hot it is and I've just burnt my tongue. It's all going wrong today. Oh, we get a bit of excitement. So I'd forgotten that I actually had some uncommitted changes to the project I wanted to be working on today. Yes, update. Yes, all the things. So that rather, yes, and restart. That means I've got a bit of explaining to do about what's going on. Again, for those who have just logged in, I am I'm going to start properly in a couple of moments' time because I started early due to me pressing the wrong button. Oh, I actually have apparently 18 people are watching. That's quite surprising. Not displeasing, but surprising. So I counsel patience. Sorry about this. This is hardly a professional production environment. I have been using the YouTube beta site, which allows me to start streaming, and then I can see the quality of the stream, and I can tweak settings, and then I hit a button to go live. But in this instance, we're using the old UI, and the old UI gives me the URL and the magical token I have to put into my streaming software, and I put it in and started streaming, and then I went to make a cup of tea, and I realized, as soon as I start streaming, I start broadcasting. So, live and learn. Yes, you can see the hunt. Well, yes, hi Pantuful. You're going to see which particular C++ style I use. So a little story about that while we're waiting to sort of get to official start time, which is now only a minute away. The one and only company I founded was a company called Profactor, and a friend and I had this great idea to abstract away the styles of C++ and the internal representation of C++ from the compiler, so that we could do all of the sort of like compile time optimization, as in the time it takes to compile time optimizations, all of the things where you remove things from header files and you forward declare stuff rather than hash include between files. We would just take that all away and just make the IDE able to sort of take a database of code and render it out to the compiler. But they could also render it out to the in the editor. So that meant that each user would be able to choose their own style of C++, and they would edit it in their own style, and then when they checked it in, it would just be stored as like tokens, and then there would be no further argument about code style, which was a nice idea. Of course, a bit of a pipe dream. It didn't quite work out. If you Google for Profactor, you'll see that there is a website still around. We got as far as making a Visual Studio plugin that did some of the stuff that we wanted it to do, but not everything. So let's just kill VR. Oh yeah, I definitely want to save that. All right. Make that go normal size. The screaming of the children. So, and I should stop saying so. I should own me saying so at the beginning of every sentence, as somebody suggested once. Today, anyway, we're going to be programming in C++. Hooray! And you can already start to see the style of C++ that I like to write in because it's on the screen right now. My idea for a CppCon talk in September. The call for submissions ends in a week. I've got a week to get together an idea and send a proposal. A call for proposals. Sorry, ends in a week. My sort of idea is to show some of the cool optimizations compilers can do by writing the same program in 3 very different ways. I'm experimenting with using one of my favorite things to write, which is some graphics code. And I'm not trying to make it the most optimal, although I'll be looking at that. I'm not trying to make it, super, use all of the intrinsics, use multi-threading and all that kind of stuff. I just want to use it as an example project, which is, not an insignificant amount of CPU work. And then sort of see how, if I write it in various different ways, how that plays out and whether or not that matters. Really, between you and me, or you plural, and me, my intention really is to try and show whether or not there's any mileage in saying, hey, that old object-oriented style of programming, where you use virtual methods and stuff like that, either we should really move away from that in favor of, say, using variants and other bits like that, or compile time stuff. I don't really know, but what I'm hoping that something cool will come out of it like that, and some kind of conclusions of the form of like, hey, compilers are really smart at doing this thing, so you can pick and choose the right way of writing the code for you, rather than worrying about, well, the best way to do it is X or the best way to do it is Y. And so I've taken a path tracer, and path tracers are effectively, they're a generalization of ray tracing. So if you've ever looked at a ray tracer which fires out beams from a virtual camera into a virtual scene, intersects them with the geometry, and then records what colors of objects it hits, then it's similar to that. But it's relatively small amount of code for a huge amount of reward. You get really nice pictures out of this. So I'm basing this on something called small PT, which I've done before. Small PT is like this is actually a reformatted version of Small PT because I can't help but hit the reformat key all the time. Small PT is a 100-line. Let me get this up actually. Bring it over into this. Small PT. Hello. Oh, I'm still typing in the wrong window. Small PT. So this is a pretty cool 99 lines of C++, and you get beautiful images like that. Now, there are some very big limitations in this, as you might imagine in 99 lines of C++, but it does work. The limitation here, for example, is that everything is a sphere in this. Although it looks like there are like walls of the box that the camera's in and there's a bright light at the top, they're actually just giant spheres brought right up to the edges of the camera. Then there are two spheres inside, and then the light at the top there is an invisible sphere, I think, with a radiance function on it. So that's kind of how that works. I'd like to do something a little bit more sophisticated than that, but not much more sophisticated. And I'd like to write it in multiple ways and not quite so grotesquely cramped into this few lines of code. So I'm using it as broadly as a template and more just to remind me how to do this. I've done it before in other languages. I learned Rust by writing effectively a path tracer in Rust, and there have been some other people who have done some great stuff with Go and written some amazing renderers in that. Again, I don't know how much of this I can get done, given how limited amount of time I'm sort of giving myself for this, and the fact that I would like to write it in multiple ways. So what I'm first going to do is I'm going to git stash all the changes that I've got. I'm going to make sure my cat has not brought in any animals. No, not today. So I'm going to git stash what I have, and I'll show you what I've got so far. And this is all on GitHub if you go and look for PT 3 ways. Let's just make sure everything works. So I am using CMake for this, and I'm using CMake not because I like it, not because I endorse it fully, but because it's convenient and pretty much everyone understands it. CMake is a meta makefile generator or meta build system generator, which should work on multiple platforms. I'm only really worrying about and testing on my own Linux box here. Although, you know, if people want to make this work on other platforms, I'd be glad of the help. But right now, CMake is convenient, and CMake is also the thing that my IDE, of choice, which is CLion here, is sort of native project format. I mean, there are metadata things as well, but essentially you can import a CMake file, and the IDE understands which files need to be compiled in what way and where to look for all of the extra files that it needs. So let's just sort of take it from the very top here. So CMake, for those who... Oh, my cat's sleeping on my foot. Now I won't be able to move very much. So a CMake file starts with a CMake list.txt in the root. CMake is relatively opinionated about where things should live, so it expects there to be a separate build directory, and originally I thought that was an annoyance, but I've come to enjoy the fact that my source code and my build files are completely distinct. CLion decides to configure CMake by putting things in a CMake-build- and then whether it's debug, release, profile, any of the sort of different build types that you can get. So you'll see that there's a CMake build debug in this directory here, which is not in source control. If we look at my git ignore, I say ignore anything that's CMake-*, because that's what I'm assuming the IDE is going to put files. It's messy, and I prefer it to be in a separate directory, but I'm not fighting the IDE. Long ago, I thought to myself that I should just accept the defaults that come with many things, just to not have to spend ages reconfiguring everything. And yeah, I'm sure fast build is much better, but I'm not interested in the speed of anything, and I just want it to be the standard thing. And one thing about CMake is, for better or worse, most things support it, and most things understand what a CMake list is. So I know there are many holy wars one can have about build systems, and I certainly don't want to start one. My personal preference is to just use raw make. I'm very comfortable with raw make, but I've been doing it for more years than I care to say. And not everyone else has. And I've been through all the mills of different other build systems. But anyway, so this is relatively declarative and it's relatively hierarchical. Now, another thing that I've chosen to do here is to use Conan, which is a C++ package manager, to get the external dependencies. And at the moment, I only have one external dependency, which is Phil Nash's rather excellent Catch2 testing library. And my favorite thing of all, and my sort of general guiding principle about as much of the software that I write, is that with the absolute minimum of prerequisite steps, one can go from cloning a repository to having it building. And Conan is one of those things that I'm prepared to say, no, you just need to have Conan. You need to have CMake, you need to have Conan, and obviously you need a compiler. And then once you've got those three things, I can get everything else myself programmatically from within the build environment. So in this instance, what I'm doing is I look for Conan, and if I don't have Conan, I complain. Once I have Conan, I can ask Conan from within CMake to go and fetch the packages that I require. So there's a few sort of boilerplate lines here of like CMake setup. And I tell Conan, hey, there's a file called conanfile.txt which lists my package dependencies. And if that changes, you need to go and fetch them again. We'll go and have a look at that in a second. Then we say, yep, I need C++17. I want to turn all the testing support on. Absolutely GGN. So GGN's just said build system wars are silly. And you're absolutely right. There are many other ways. And I don't mean to be negative about your choices there at all. I'm just like, I just don't want to get into it. Although then I immediately went into it, of course. So I want wall, wara, and wextra. Now this is a point where obviously these are very specific to Clang or GCC compilers. So I'm sure there's a better way of doing it. I'm hoping someone will tell me. I'm going to add source and test as subdirectories, which allows me to hierarchically define further CMake sort of setups down the line. And then I say, hey, there is going to be one executable called pt3ways. It's main.cpp. And I don't even think I've got anything in here. Yeah, this is the default thing that CLion made. So actually the whole way that it started was me to just go file new project in CLion, and it created and set up a CMake project for me. So that is how that bit works. Now let's go and have a look inside. Oh no, first of all I said about the CMake lists. So if we go and look in the CMake list.txt, sorry, the Conan file.txt, here we can just see that I'm asking for catch 272 tagged in this way. The catch org/stable is a Conan specific thing. It's called a channel, a username in a channel. So you can ask who publishes it. Conan is aware of what compiler you're using, which things are important, so that it can match the binary packages it might be downloading. In this instance, catch2 is a header only, so we don't really care about that. But we have it can go and get the right binary version that's compatible with your version of the compiler with the flags that you're setting as well. So there's some cleverness going on behind the scenes. It's not perfect, but it's a lot better than some of the other solutions that I've seen along the way. And there we go. I'm just going to move away from that. So that's how I would say. Now, if I wanted to depend on Boost or something like that, I could just add Boost in there and it would go and get Boost, and that would be great. And I don't really want anyone to rely on packages that are globally installed on the computer. It just annoys me that I have to sudo apt-get install something or other. So yeah, this add executable and this target link libraries is not actually used by anything. I don't think it just literally does hello world. And that doesn't do anything useful. Let's have a look in source. In source, we've got another CMake lists, which just adds subdirectories. And so I can build smallput, and this is the original, if you remember, thing that I said about. And smallput needs openmp, and it only comprises of one file. So I just define it in that way, and that adds a new executable called smallput, rather unsurprisingly. Then inside the math directory, which was the other directory I've got over here, I've started working on what will be a very, 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 very simple math library. I don't want to pull in too many other big dependencies, and I want to be able to play with things like whether or not something's constexpr or no except or not. So at the moment, this is like my big fat write everything myself const no except constexpr math library. And I'm learning already that that not many math functions are in fact constexpr. So if I need a square root, for example, I'm out of luck because the square root, at least the one that's defined in the standard library, is not constexpr safe, which is not too surprising, right? I mean, floating point in general is not very constexpr friendly. So someone's just said, you really like CLion but can't seem to understand CMake. Would you care to explain how to create makefiles? That's a whole other category of things. I'm not going to have time to talk about that today. There's makefiles and CMakefiles are very different ways of doing the same thing, but they really fall outside the scope of what I've got time for today, but sorry about that. I'm sure there are plenty of tutorials. If anyone in the chat knows anything about where someone could learn about how to write makefiles, then please post it in there. Or ping me on Twitter or something and I'll try and find something afterwards. Okay, so that was the source directory. In a moment, we've just got small point, which is just there for like reference purposes and the beginnings of a math library. And of course, I don't have an executable yet, but I have a test for it. And so this is what the test directory looks like. Let's just have a look in here. And here I'm saying, hey, add an executable called math test, and it's the math test, and it's the vector, and it's got math test.cpp twice. So there's a mistake. So we should get rid of that. Except I've got a stash that I'm going to undo. So I'm going to undo the stash, and then I'll go and change that. Surprised it didn't break, actually. Then here I'm saying I need to go and get catch 2. I link with catch 2 here. So this says go and find catch 2 from this Conan PKG, which is something magical that Conan has done. That means that all of the includes of catch 2 become available to my project, and I will link against it. And then I say, hey, there's a test that if you get called math test, which you get by running the result of having compiled math tests. So it's a bit bit long-winded, but you write this stuff once and then you get on with your life. And math tests, this is just like a main function. This catch is a header-only library, and to save me building all of the library every time we'd include catch.hpp, I build the main function only in one file by just this trick, and then everything else just includes catch and just goes around using it. So here, the IDE is going to take a moment just to colorize and syntax highlight all the stuff that's going on here. This is what a catch test looks like. You define multiple test cases. In this instance, I've only got one test case, and I've just got multiple sections. Each section, and the sections can be nested. Each section is run exactly once and has a little helpful piece of text that goes alongside it. And here I'm just sort of checking like the obvious stuff, like an empty one ends up being 0, and I can construct one, and I can read the values out, and the lengths and normals and whatever. And does it stream out and look like the way that I'd expect it to? So that's a broad overview of where I am. I'm now going to git stash pop. Thank you, GGN. So GGN, I think, is explaining the real question that Abidan was asking, which is how to make files from CMake. But you don't. If you're using CLion, you don't need to worry about that. If you're just building in the IDE. If you're not building in the IDE, then you can follow the instructions that are in the chat right now. Okay, so I've git stash popped. Let's first of all go to that CMake list and make sure I haven't got a double thing. Math test. Yes, there it is. So we can already first actual useful test. And I'm just going to build everything just to make sure everything's up to date. So the IDE will notice all of the different, I don't know why it's popping up in the wrong place here, but this is meant to be a drop down from up here. The IDE notices all of the executables that can be built, and so it gives me them as lists here. So I got PT3 ways, math, small pt, and math tests. I can actually pick them independently. So math test is just built, and I can run math tests. The IDE understands that catch2 is is a testing library. It knows how to run it, knows how to minimize the amount of tests that actually run, and it knows how to parse the output, so I get pretty information like this. So although it's actually just hiding all of the tests that passed, you don't care about those, it's only the ones that failed here. So let's go and see what I was doing, and I'm going to remind myself. So I'd written as much as the vector3 tests before, and then I was starting to write the other primitives that I would need, which would be like spheres and rays. So a ray is a line with an endpoint and a direction. And in fact, do I store it as an endpoint as a direction? Yes, I do. An endpoint and a direction. And a sphere obviously is a point, a three-dimensional point, and a radius. And a vector3, this is just old habits dying hard here, that I put the 3 actually in the name, and so that it's actually different from other libraries that I've seen. So this is a three-dimensional vector. It's just an x, a y, and a z. And you'll notice I say z and z interchangeably. I'm sort of completely gone native. And so you can kind of see my style here. Just from a coding point of view, I tend to put my opening braces on the same line as the function that's defining it. I like to kind of keep as much vertical white space free as possible. As you can see, I have a relatively high limit on the right-hand side here, but I've been known to set it to 80 columns before. I spent a while working at Google where their recommendation was 80 columns, and I got used to it. I don't mind it. It certainly allows me to fit more things side by side when I'm working on the laptop screen, which is over here. It's a much smaller screen. So I've got various useful things, and a lot of these are speculatively written, in fairness. I mean, this comes from my experience of having done this a number of times before. I know the kind of math operations I'll need. And interestingly, so like here, length squared, which is the length of a vector3, squared. Why is that a useful thing, you might think? Well, in order to get the length of something, you obviously use Pythagoras' theorem. So you do x squared plus y squared plus z squared, and then take the square root of all of that. But as I've said before, square root, first of all, is not const expr, so I can't do that at const expr time. Secondly, many times I'm using this for a comparison, and the comparison oftentimes doesn't care about the actual magnitude as such, as whether it's positive or negative, or I'm checking it against a constant. So if I'm saying, like, if the length squared is less than some constant, do some work. Now, a square root is a really expensive operation, or certainly it's a lot more expensive than your average multiply or add or subtract. So if one can avoid it, one should. And of course, the one way to do that is to, instead of compare the length with a constant, you compared the length squared, which you know is considerably cheaper, with the constant squared, and you just take the hit of squaring that constant once. Horses for courses. So anyway, length squared and length are there, and you can see here, like, length unfortunately can't be const expr because it calls squirt, and squirt is, again, not const expr. Yes, so someone's saying about the formatting was redundant. Use one format and work in code and pushing. That is not totally true. So if you were here earlier, Luca, I was telling the story about the company I set up to sort of work on a product like that. It's mostly true, I think, except in the cases where one, and this is what we found when we were working on the project, was that there are sometimes sort of semantic meaning in the way one chooses to format one's code. So, for example, right now I am actually using the internal Clang format support inside CLine, and I specified a .clang format, and it's very proscriptive, and it formats everything in a particularly uniform way. And that's kind of okay. It certainly means that there's no arguments and we can change it and whatever. But for example, here, in fact, we're about to come down to one of the things where it works out. Naturally, I would write this code like this. So vec3, x, y, z. So this is a cross product between two vectors, and it's a complicated, you know, as you can see, y times the other guy's z minus z times the other guy's y, and all that kind of stuff. And so this makes a lot of sense to me. I'm calling out that the new x is this, the new y is that, and the new z is this last thing here. But if I auto format, which it wants to do, it will always line it up like that, because that's what the format looks like. So that is sort of an annoyance, and I guess I could, while we're here, I can do something like auto new x equals, and I don't know why my computer has decided to go so slow. All right, let's do this with the IDE. So this is a bit of a free ad for why I like the IDEs, and it's not normally this slow, as this is definitely something that's going on with all the recording that's going on. So I can extract a variable here, and I will call this x, and I'll call it auto, yep. And then I'm going to make this one, and extract a variable and call it y, slow, and then this one here, and this one z, whatever we're going to call it. Right, and now the auto formatter should give me the layout that I wanted, but I had to change the way I wrote my code to do this, and I don't really like that. I'd have liked to just left it like that. And of course I can put in some like comment blocks to preface around the area that I want to format my way. Of course, if you do that and then you ascribe to just everyone picks their own formatting tool and they sort of use it when they edit it, then you get some horrific like chunks of someone else's format in the middle of your code, and that doesn't work out so well. So that's been my experience anyway. Anyway, so we've got the cross product, we've got this dot product here. A common operation you want to do is take a vector and make it point in the same direction, but with the length of 1, and that's called normalizing. That has an interesting side effect here because we have a division going on here. So this divide by length here is a divide. Now, if the length is 0, we blow up here. That's not a great thing. That's another reason why this thing can't be const expr. Yeah, yes, of course, Alexander. You can come up with any number of ways to hackily put things on lines and stuff, but I don't want to do that, right? I want to make it so that like my code looks the way that I want it without like fighting with the formatter, and certainly that then yeah, thank you, Pantufel. That makes some sense at least. I mean, I feel like at least this doesn't look materially worse than it was before, and I don't have to fight the formatter, and I've also improved it rather than relying on a sort of glitchy. Well, if I put a comment here. Of course, it'd have to be a // comment. I think if it was a /* comment, I think it would wrap it. Anyway, it doesn't matter. Formatting is not something I want to get too het up on. What I want to do is go and say, well, here's the vector class, And the vector CPP class, I mean, so just sort of on a matter of personal style here, I like, wherever possible, to leave the implementations out of the header, except where ahead of time, a priori, it's going to be constexpr, or it's going to be so trivial and I'm not likely to change it again, or I just absolutely want to give the compiler the biggest, fattest hint that this should be inlined. So all of these are implemented in the header because I'm expecting and anticipating that I should be, they're trivial. Oh, crikey. 2 birds just flew into the window over there, and then they've gone around the house. Gosh, very confused, obviously, poor things. Oh. So this is a... What was I saying? Sorry. Distracted there by birds. I was saying something about my styles and something, and... oh, golly, I can't remember now. And now, unfortunately, because you're several minutes behind me, by the time you actually tell me what I was talking about, I'll have moved on, which is a shame. So apologies for losing my train of thought there. And yeah, someone's just joined and said, what am I coding today? I don't know how much coding I'm going to get done. I'm already 25 minutes into this, and I've changed like 3 lines of code so far. So yeah, I was talking about my sort of thesis for putting things in header files. And well, first of all, the thing I'm coding is a path tracer, or a very simple path tracer, which is like a ray tracer. The new thing that I was talking about was whether I put things in headers or where I put them in CPP files. And actually, one of the things I might want to do in this PT3 ways is to actually put everything in CPP files or put everything in header files. That might be an interesting thing to distinguish between, and see if the compiler with link time optimization is smart enough to inline the things it needs to inline anyway. Obviously, with constexpr, we don't have that choice. We're going to actually have it already. We're going to have to put it in the header file because everything needs to see the implementation of anything. The implementation in order to be constexpr. I think I've just gone around in circles about 3 times, so forgive me. All right. And see, Clang wants to put that on the same line all the time. I would normally break the line there just for clarity and just say, hey, put it there. But Clang is currently there. I'm sure I can fiddle that with the formatting section, but sometimes I do want to do that, sometimes I don't. It's like, if it's more than 70 characters, then you might as well put it on the next line. If it's less than... These were the kind of things that Profactor's Style Manager, the product I talked about before, had all sorts of special settings for, and I haven't yet found that Clang format has that level of specificity. Okay, so yes, Vec3, the one thing that is in the CPP file is the streaming operator, because my thought there is that, hey, I might change the way the streaming looks. I don't necessarily want people who are using vec3.h to pick up the full expense of iostream.h, hence I'm only including iosfwood here. And then I define the streaming vector out of line, and obviously then in the CPP file I have to actually include iostream, otherwise things don't work. So I like to keep my header files as hermetic and as minimal as possible, but sometimes that's not the case. Let's, for example, go and see whether or not I've kept to that by looking at the sphere. So sphere here, haha. You can see I'm sketching here, very much in sketch mode here. This hit I would never really define anywhere else. Sorry, I would always define somewhere else. I would never define 2 classes in a header file unless they were totally tied together. And then if they were totally tied together, I usually make one a subclass of the other. And that might make sense here. In fact, for now, I think I'm going to do that. I'm going to make this a subclass of this, of the sphere. Later on, I'm anticipating that each individual type of object that you're going to interact with will probably need its own hit record to say, hey, yes, this intersected with me and I intersected with it here, and this was the normal at that point, and this is how far away it was, and things like that. But right now, we only have a sphere, and I'll worry about that when I get to it. But you can sort of see some of this kind of like me thinking out loud here. And all this code has been written on the train so far. I haven't really spent too much time thinking about it. So a sphere has a position, apparently. So let's go and rename that for a start. Let's fix that typo. Position. And it has a radius. And right now I have chosen not to store the radius squared. But that would be an option, right? At the point at which I'm constructing a sphere, I could just square it. And then this line down here, which we use later on, remember I was saying about trying to avoid that expensive square root, that could be avoided. But I think, on balance right now, squaring a value is cheap enough that I'm going to say it's free. So a sphere is essentially 4 doubles There are 3 inside the position, the x, the y, and the z, and then a radius. And so you can construct one, and you can interrogate the bits and pieces that come out of them, and presumably I've written tests for this. Yes, look here, I can construct a sphere, and I can read out the values in it. I mean, it seems banal, it seems stupid to do this, but oftentimes you do actually find bugs this way, especially as a sort of top tip. Don't just do, like I've done before, vec3, 1, 1, 1, and then a radius of 1, and then asserted that you can read that out. Because obviously, if you transpose x, y, and z somewhere along the way, you won't be able to know if everything's a 1 anyway. So always pick different values for the random constants that you're otherwise going to test for. So yes, a path tracer, is that math heavy? It depends what you mean by math heavy. The CPU is going to do tons and tons of math. It's going to be doing very little other than maths. But in terms of the things you need to think about as a human understanding what's going on, it's relatively straightforward. Relatively straightforward. So this algorithm I used to know and I have derived before now, but I'll be honest with you, I completely and utterly copy-pasted out of the small point code and then rationalized, renamed, gave it sensible variable names, and rephrased it to have as minimal footprint as possible. There was lots of ternary operators going on in the small point to sort of like trick out and get it onto fewer lines of code, but obviously that's not my intention here. So let's take a look at what this intersection is doing. We're given an array, and array has a position, some point on the array, and then the direction along that array, and it's considered to be infinitely long, at least at the moment. Something I need to think about is whether I do actually need to bound the array, because there may be times when I want to find an intersection that's shorter than a certain radius, but shorter than a certain distance, or within a sort of line segment as opposed to this infinite line. So Lucas just made the point the CPU does generally very little other than math. The CPU is mostly waiting for memory and trying to predict and mispredict and deal with mispredicted branches, in my experience anyway. But the kind of code that I work on doesn't do very much actual, what I would call maths. I mean, okay, yes, you're right. Like loop counters and stuff are always adding and subtracting and comparing and all that stuff, and that's broadly math. But like in terms of actual double precision mathematics or stuff like this, transcendental functions or square roots and stuff, that it doesn't tend to do that all that much. All right, I'm gonna have a sip of tea, horrible black tea. Yeah, and I burnt my tongue. I said earlier I've run out of milk and I should go shopping and get some more milk, but I didn't bother, and then I started the stream early. Ugh. Okay, so let's sort of run through this intersect code. It's const, it's no except. It unfortunately can't be const expa, even though that was my kind of hope, and that's because there is this square root down here. Now, I'm optimizing, maybe prematurely, probably, I don't know. I'm optimizing by using the squared radius here rather than the square root ahead of time, because my guess is that for the most part, rays will miss spheres. Most of these intersections will fail, and so I want to do the cheapest way of determining that I'm never going to intersect with a sphere as possible to get this out of the way and done. Do I actually write code like this at work? Not. I mean, this is how I would write C++ code in general, but I don't write code like this. And if you mean like this, I don't quite know. No, I don't write graphics code for a living anymore. I did about 15 years, no, more than that, 20 years ago, 15 years, something like that ago. But nowadays, I content myself with code that's more in the finance world, where we don't tend to use double precision for very much. Yeah, this will make it do math. All right, so we first of all work out, we get a vector between the position of the sphere. So this is the center of the sphere. I should really call it the center, shouldn't I? See, this is where an IDE is nice. I can rename this to call it center, and I'm going to call it the British spelling of center because I can. And I'm going to rename this center as well. I keep spelling it American even though I don't. And I'm going to rename this to be center. This is where an IDE is nice, when it doesn't take too long. Comments and non-code. So let's, all right, so now it's detected that the word position has been used in like comments. Let's just have a look at what those comments are, because obviously comments usually rot. So these are the ones it's definitely going to update here. These are all code, which is great. Here I've got notes. I know I'm going to update my notes, so we don't want to do those. No, not those. Position, also color, that's in small point, absolutely not inside small point. Okay, so we're going to do the refactor, and we're not going to actually change anything else about it. Cool. All right. So, back to line 27. Gosh, we're not going to get very far. So we're going to find this ray, which is between a point on the ray to the center of the sphere. So if you imagine in 3D, I should probably have some kind of way of drawing, shouldn't I? I mean, I have got a pen and pencil, but yeah, I mean, realistically speaking, the tiny little me up at the top corner of the screen is not going to be good enough, is it? So just use your imagination. We're going to have the sphere. We've got some sphere in space. We've got some line, some ray that's going to be fired through space, and we're going to work out where and whether they intersect. First thing we do is we get a line from the point on a point on the ray to the center of the sphere, and then we're going to use a dot product between those two. And then if we take b squared minus the length squared, that's going to be the closest approach, and then we add in the radius squared. So we're saying if the closest approach between the ray and the sphere is, in this case, less than, well, I've confused myself about this. I should have really looked this up before. But effectively, we're finding the closest approach point, and if the closest approach point is greater than the radius squared, we know that the ray never actually touches the sphere. And that's kind of what's going on here, except that this determinant value here is the other way round. And we know that if it's going to be less than 0, that means that the closest approach was never anywhere near the sphere. That allows us also to do a square root here without falling foul of a negative value. So that's good news. And I toyed with the idea of making a const extra square root by using like a binary search, but let's not do that. And that would be cool because I could use the new C++20 of stud is constant evaluated, so that I can actually then use the regular squirt in runtime, but I could use like a const expr safe square root at compile time. But realistically, who's ray tracing in the compiler? I mean, you could. Now, as you know, for these things, there's going to be 2 points of intersection. Almost always 2 points of intersection, and that is where we hit the front of the sphere and where we hit the back of the sphere as the line goes through it. But obviously, depending on which way round the ray is, those two could... what is the word here? We need to find which of those two we hit first. Now, if both of those are so grazing that they don't touch, we say there's no hit at all. Otherwise, we now know how far along a direction of the ray that we're intersecting with the sphere, and we can get the position along that, and that gives us the point which we're hitting the sphere. And then the normal at the point of a sphere. So the normal is the way that the surface is pointing out at the point of intersection. It's used for lighting, amongst other things. The normal of a sphere is always pointing directly out from the sphere. So having just found a point on the outside of the sphere, this hit position, we know that the normal will be a vector from the center to that hit position normalized. That, as in just like a unit length direction vector in the direction from the center of the sphere to the point on the edge of the sphere that we just hit. All right, that's a lot of talking. That's a lot of talking and not much C++, which has been sadly the way these things have gone so far. And finally, I will see if the refactors all worked. We don't have any compile errors. Thankfully, we do not. And now the test will rerun, and hopefully we'll have the same failing test. Hooray. And let's go and see what that failing test is. So here are these sphere tests. I just made up some spheres, I made up some rays, and I just asserted some things that are going on here. Right, so I remember where I was. So I'm sort of doing a tail wags the dog thing going on here, where I ran the tests, and I looked and saw if they looked feasible. I sketched something out on paper, and I went, does that seem about right? So this is not really a recommended way of testing from this, but I wanted to get something down. So I made up this sphere, and I made up this ray, and I made sure that trivially a ray that I could clearly see was hitting the ray, sorry, a ray that's clearly hitting the sphere hits, and clearly a ray that isn't hitting the sphere misses. Just sensible to have a couple that miss and one that hits. And then I've sort of just squinted and sort of said, well, this looks about right to me. Now, one thing you'll notice here is that obviously, once you start using double precision maths for all this stuff, it's very hard to write tests. Now, if you've got 10s and 20s and 30s and 15s and other small values for which you're doing no calculation on, then you're going to be mostly in luck with the operator equals. I mean, you've probably seen this before now, that one shouldn't use operator equals, which is what the test system is using under the hood, for double precision numbers. Now, that's fine if you're doing any kind of calculation on them or they're not representable. You're using values that are not representable as double precision maths. Now, 10, 20, 30, these kind of numbers are all perfectly representable as double precision numbers. So we're good with those. So I've been able to just use comparisons in the main. But once we started saying how far along this line did the intersection come, I've had to use this approx class. And approx is something which Catch provides. So I'm just going to go to definition here and we wait a moment or two while Catch comes up. And it's it wraps a double precision value and then it overrides the internal Catch testing mechanism to give some amount of margin. So you can have something within a small amount of margin, and that defaults to float epsilon times 100, which is still a tiny, tiny, tiny value. Although actually that's interesting, it's float epsilon and not double epsilon. Intriguing. I don't know why it's that. That's a lot bigger than I was expecting. It's still tiny and it's still perfect for our means. Maybe I should talk to Phil about that. I'm sure someone cleverer than me has thought about it though. So that's groovy and cool, and it allowed me to check that the distance is approximately 22.41638, which passes. And it looks literate as well. I like to see lots of literate programming where you can kind of pretty much straight away see what's going on. Unfortunately, it didn't work for vec3, which of course is three things, an x, a y, and a z. Now I could obviously go check that hit position.x is approx something, and y is approx something, and z is approx something. But I figured I would learn the mechanism by which this was working, and I made my own approx vec3. If I'm going to be writing a lot more math tests, I'm certain that this will be useful. So an approx vec3 has is constructed with x, y, and z, and then it defines the operator equals, and it's defined in terms of an approximate one is equal to a real vector 3 if the distance between them, the length squared between them, is less than the epsilon squared. Make sense? And obviously it needs a streaming operator here, which I've done, in this case I've done as a friend, and it says approx v, and that v here, this will have open squiggly braces, and it'll have like x, y, z. So it'll be approx squiggles 1, 2, 3, something like that. And then you can see what I've done here is I've obviously written the approx vec3 for the... Whoops, sorry, cat. Just see, I told you I had to keep my foot still, or else I would kick the cat. Sorry. She's all right. She's sat on like where the power supply is, so it's warm. Approx vec3, but I haven't written the equivalent approx vec3 for this normal because I hadn't got around to it. So this is the unapproved method of testing. I'm going to take the output of the test and I'm going to put it into the input of the test, thus making the test pass. Never do this. So before we even think about allowing this to run and checking that it works, which it will, we're going to at least make it some kind of qualification that this is the right thing to do. So I have a blank bit of paper here, which is actually a copy of the, I say it's blank, somewhat blank piece of paper that has a partially printed out copy of my agreement with my previous employer. And I'm going to draw out a sphere, which is at 1, 2, 3. So I'm just going to do it in 2D at 1, 2. And then my ray, which is from the origin to the center of the sphere in this instance. So we know that it should be pointing backwards toward the point where we hit should point exactly back towards the origin. So the ratios of these three things should be roughly 1 to 2 to 3, which it looks like to me, and the signs look good too. So I think this looks about right. So I'm going to run the test now with my literally finger in the air test, and unsurprisingly it does indeed pass. So why don't we add another test where we can derive the position like totally obviously. So we call this S2. Actually, no, we're going to say intersects, and then we're going to have... we're just going to have another section called intersects 2. I'm not very good at these names, and I need to learn more about how one does testing. With... Alright, TBD. So one of my hallmarks is to try and not get myself stuck on the names of things. So that's unfortunate So I'm going to put TBD until I've written some code, and then I'll develop a better name about what's going on. So let's have this sphere, and we're just going to put it down the z-axis. So it's going to be the origin everywhere else, and it's going to be 30 units down, and it's going to be 15 units wide. And now if we fire a ray directly at it, so I'm going to have a point from the origin directly at 0, 0, 0, and then I'm going to make this 1. I'm actually going to use something which isn't directly the center of the sphere, just to mix it up a little bit and make sure that I'm not getting a factor of the scaling value. Let's do it 2. There you are. It's neither 1 nor directly at the center of the sphere. That gives us a bit more coverage. So we require that we have a hit here. Now, in terms of my sort of theory on these things, I tend to use check check if the values don't work out, the test prints an error but otherwise continues. Whereas with require, if the check fails, it prints the error and then it stops that particular section. So anything where you absolutely 100% rely on the value, like it will crash if this thing is not set, like for example require hit here, I will use a require. And then for other things, I generally use check unless it's in a loop. And the reason for this is that sometimes if you stop on the first failure, you don't get as much information out. So imagine you've switched two values around. You know, you've got some things, your x, your y, and the z, and you've got y and z the wrong way round. If your tests are check x, then check y, then check z, you'll fail if you've got them the wrong way around when the y check fails, but you won't get the extra information that might be obvious if you also saw the result of the z check. Because if you saw got 1 expected 2 and got 2 expected 1 as the 2 lines of output, that's a real big clue to, oh, I got those the wrong way round. Whereas if it just says got 1 expected 2 and stops, you don't get that information. So I tend to use check quite a lot more than I've seen other people use. So we have distance, position, and normal, and we know that the distance here should not be approx anything. Well, it still probably will need to be approx for all the calculation reasons, but we're going to start off with it not being approx and then go from there. We know that the distance between a ray that's going from the origin to a sphere that's 30 units in the z direction, but is 15 units big, should be exactly 15. We're meeting it halfway. The position we know should be at... I'm going to get rid of this approx for a second now. It's going to be 0 units of x, 0 units of y, and 15 units of z. Which actually makes me think, you see here, I've broken my cardinal rule here. We've got 2 things. Now, if I switch those things around, I wouldn't be able to tell. So I'm not going to make this 15 units away. I'm going to make it 10 units away, so that the distance, the sphere is going to be 10 units wide, so that we know that the distance will be 20. So will the position. So will the position. The position will be 20 units away as well. So, okay, I haven't saved anything here, but anytime you've cut something in half, and you could potentially see both halves of those in a test, then it makes sense to switch it up so you don't actually cut it exactly in half, so that you can actually discriminate between whether you're returning like the distance before and distance after the right way round. And we know that the normal should be pointing directly back at us, 0, 0, minus 1. And I've left that as a prox vec3, shouldn't really be. So I'm expecting to see, yeah, I'm actually surprised that the vec3s in the 20 did work, so I'm just going to do it again. With the approx taken off the normal, that would be the one I would imagine would be the most likely to be wrong. Okay, so sphere at known intersection point. Now I've got a better idea about what I'm going to call it. Okay, so we have some working tests. So that's the sphere done, and we have a vector changes. There's a whole bunch of things going on in here, but ow! My cat is now choosing to use my foot as target practice. I am going to check that in because that's like good enough for me. Now I have got a Travis for this as well. Travis is a, and this kind of answers one of the questions that was asked earlier by Abidan, and I apologise for butchering your name in this. this is like the minimal setup for how to build without an IDE. So I'm literally just creating a debug build and then telling CMake to build it and then running ctest on that. So that would be, this is the manual way of building and running the project. And everything else here is just the setup for Travis itself, just making sure that Conan is installed and initialized, which is what that Conan user does. So that's pretty straightforward. Let's commit -m, and I can't read the bottom of my screen because I have a glass in the way. And all right, let's just see whether I've changed in total. So we fixed that problem in the CMake lists. Oh no, that was a different thing. That's this CMake list down here, where I've added new tests, but I also got rid of the duplicated math_tests.cpp, which we spotted earlier. We've got a bunch of new files, new array, we've updated vec3.h with that changed, which hopefully makes things a little bit clearer. Certainly scratches my itch for wanting things to look the formatting that I would like. And I renamed tests to be consistent, and we fiddled around and we added tests. So this is adding rays and spheres and tests. That's pretty much what we've done here. So I'm going to say adds rays, spheres, and tests for same. I'm not saying these tests are comprehensive for what it's worth. This is still really sort of sketching territory. Fabulous. So that is now checked in. So if you are playing along at home, you can go and grab that code if you so wish. And oh, it looks like we're set to 80 characters here. Is that 80 characters? Yeah. All right, I've got my line set at 80 characters. I don't know why that was earlier. It was right out here, wasn't it? Maybe that was a CMake list file. Yeah, maybe so. But yeah, I'm trying to stick to 80 characters, if only because then I can do this kind of stuff. And even on this giant monitor, although I've got it zoomed in for you folks to follow along at home, I can get two of them comfortably side by side without scrolling left and right on them. Okay, I have spheres and I have rays, and what was the thing that did it? Was that hit? Yeah, so that hit class there, I'm imagining will become a general purpose separate object. So why don't we do that right now? It may be premature for this, but I'm just going to say new C++ class. It's going to be called hit, and it's going to be added to math, and I've tricked out the IDE so it doesn't generate all of the rubbish that it usually generates. It's complaining that it's not belonging to a project, but it is. There you are, you worked it out. It's called class hit here. Now, because my general feeling is that if it's just literally pod like this, plain old data, then I usually make it a struct. And that's kind of an indicator to me. Obviously, classes and structs are exactly the same thing. They just default to different access primitives. Sorry, access control. So if I put that inside my hit class there, hit class is complete. There's nothing really else I need to do. I'm not going to add accessors and getters to this. It doesn't make any sense at all. Yay, fish, exactly. Yes, that's right, fish shell. And it's a custom git status command that I have. Git status in my prompt. If you go to my repository of my GitHub repositories, you'll find something called .files, and that has my configuration there if you want to play around with it. Oh, and the IDE is being helpful here. So we want to include vec3. And this empty hit.cpp is sort of pointless. I'd be tempted to remove it, but I imagine at some point I'm going to need to see out these things or define stream doodads for it. Streaming operator, that's what it's called, not doodads. All right, so obviously this now is not working. So the IDE said, hey, did you mean this? Oh, I did mean that, thank you. So that refactoring was relatively painless. Okay, no function matching function to hit. Because it's still a class. Let's make it a struct. Okay, that was straightforward enough. Shall we try and write a ray tracer? A really simple one. So I'm going to hack that main.cpp right now, the one that currently does hello world. And in what little time I have remaining, I am going to PT3 ways. So this clearly is not my intention for it to look like this for any length of time. But I don't know about you. I'm a creature of wanting to see something pretty quickly. And that's why I picked something like ray tracing here, because with relatively little code, you end up with something pretty cool pretty quickly. So this is going to be super scrappy, and it's going to be super hacky, and I hope you'll forgive me for it, but we're going to try and write some code. So this, now you get to see, like, when I'm not on my best behavior, what my code looks like. So I'm going to start with, we're going to need width and height, we're going to need a position in the world, and this will hopefully inform what the rest of the system will look like. And what I really want to do is, taking a step back again, is at the moment, obviously, I just want to check that I can render a sphere in the middle of something by hard coding it completely. Down the line, what I want to do is allow for a graph of the scene, and that graph is where really I think the guts of this talk are going to come out. We're going to have like various different ways of intersecting array with a graph of objects, be they virtual methods on things or not. So right now we're going to use like the raw primitives that the math library gives us to do this. So let's do auto width equals 640, because that's the one true size. Height equals 480. We're going to say vec3 cam pos, and we're going to initialize that to the origin. So we're actually going to do that scene that we talked about before. Vec3 import, yes, from math vec3.h. Beautiful. Let's see if that even compiles, because I've got a feeling we're going to have linker errors straight away. And it's going to tell me about unused variables. Of course it is. So return. Let's make them used in the cheesiest way possible. I mean, I could put the no. Let's do it the right way. Maybe unused, just for now. Drum roll, everybody. All right, amazing. It actually compiled. Will it run? Hello world. Let's get rid of hello world. We don't want to print out hello world. So we've got campos here, and let me just get rid of those with the cool rectangular selection thingamajig. And we're going to just do sphere, and the sphere needs a vec3, and the vec3 is going to be at, so what do we decide? 0, 0, 30, and it's going to be 15. Hooray, we tested this, right? Will I program until I finished, or 1 or 2 hours today? Good question. I will do my best. With external forces notwithstanding, I will get to the point where we can at least see a black and white sphere being rendered, and then we'll take a call after that. So we'll get through creating a virtual camera, doing the math of getting the ray through the plane of the camera, and outputting the world's crappiest image file format, so that we could open it up in the GIMP, the GNU image manipulation program. So that is where that's my plan, unless like I totally get this wrong, or my phone rings and I have to answer it or something like that. That's where I'm going with this. So hopefully you'll stick with me for that. I'm not anticipating it will take more than half an hour, but programmers are extremely good, as you know, at underestimating the amount of time anything takes. And if this goes really, really well, we'll start to extract a scene out of it and see how that goes. So we've got a sphere, we've got a camera, we need a camera direction as well. And I could make a struct with these things in it. So 0, 0, and we're going to look. This is going to be like the downward direction, the away from direction. 0, 0, 1. In fact, sometimes it's just easier for one to just have an actual direction in the camera. So no, all right. Okay, sphere. We'll do 4. Oh, sorry, I thought someone was at the door. For int, how are we going to do this? We need to count from, int x equals 0. Well, we're going to do y first, obviously. Y, and let's use auto. Y equals 0. Y is less than height. If I could type, it would really help this process. Visual Studio and SVN for personal projects. Sure. If you're on Windows, it's a great choice. SVN, I'm pals with some of the people who developed SVN, and they're lovely people, but I wouldn't use it. I used to use Perforce at work, and SVN I see is like the open source Perforce, and it's great at what it does. It doesn't work for my use case of mostly programming on the train while I'm commuting in and out of work. My cat is moving again. All right, so if we are at pixel XY in our screen, we know that we want the center pixel to be pointing directly down the camera direction. So there's another thing we need, and that's the field of view. And then I'm going to have to steal, I think, auto field of view equals, what do we reckon? 60 degrees? We're going to turn that into radians in a second, I'm pretty sure. And I think I'm going to cheat in a second and look at the small PT source code. But I'm sort of trying to derive this as much as possible from memory, whilst not boring you while I kind of work it out. So I'm drawing a picture on the paper here of a point, which is the camera. We're going to have some kind of... so the camera is obviously a single point, but our screen is a swathe of rays at some distance from that camera. So if you imagine holding your fingers up like this, and I hope you can actually see, I can't see on my... then obviously depending on how far or near that plane is away from the point of the camera, which in my instance is in my eye, we get a different field of view. And we want to, so that's what we're tracking with the field of view. Is like, are the rays going to go out like this, and like this, and then like this, and like this, all the way over to the far ray over here? Or is it more like a smaller view where the first ray is going to hit there, and we're only subtending a few degrees of my view here? Okay, so we're going to need some kind of, I'm going to just call this XX for now, and there's going to be a constant for Y as well, but we know that this is going to be x minus width over 2, and I'm making this a double because everything else so far has been an integer. So this is the amount, and then this is over, actually no, this would be x, double x, so let's use auto, xx equals static cast double of x over width. So that will give me how much of a ratio between the of the field of view we're in. Now, of course, that's a value between 0 and 1, and really we want it to be centered around 0. So 0 is going to be straight on, plus 1 is going to be to the far right, and minus 1 is going to be to the far left. So this whole thing needs to be times 2 minus 1. Any number of ways to do that same calculation there. Is that right? A value between 0 and 1. We multiply by 2. We get a value between 0 and 2 now. We subtract 1. We've got minus 1 to plus 1. Brilliant. Okay, that seems to check out in my head. Yes, Pantufel, I know what you mean. I have problems with words too, as you're discovering more and more as I'm talking to myself here. We know that there's going to be an equivalent of this for y. And I don't like the name yy, but we'll come back to it. And this is obviously going to be y over height. All right. We need, so that's 644.80 also traces it. So I've done the field of view. This is going to be like a field of view x to y. So that's like the x field of view. The y field of view will be the same. Auto y field of view equals, that's going to be that same thing divided by the aspect ratio. So let's do this. We're going to say, I should probably make all these const auto. And const y field of view equals 60, and then we're going to do 640 over 40. Of course, we know those things are actually integers. I'm going to call that out, you know. I'm going to call these out as ints because it's at the moment it's unobvious to me that when we're switching in and out of the domain of integers with integer division and multiplication rules and non-integers. So I think that's the right way to do this. Whereas these other things, it's pretty straightforward what type they are. Make sense? I hope so. So over, well, let's do, darn it, stat const double aspect ratio equals static cast double of width over height. Is it width over height, 640 over 40? I never really remember which way round we should do the aspect ratio, but as long as we're consistent, it is still generally correct. So at this point, if our x field of view is that, we need to divide by the aspect ratio here. All right, this is all very dreadful and doesn't give me much confidence that things are going to work the way that I'd like them to work. I was going to see out them and just run it because I've reached the point of like I've written so much code and I haven't run it through the compiler and it's not even going to compile because of all these things that aren't being used. So I'm going to cheat now. I'm sorry. You can be disappointed. I'm going to move this over to the move to opposite group, and we're going to have the horrible, hard to read small point code over here. Somewhere at the bottom here, we can see how small point was doing it. Over image rows, X does some white loop over columns, and then it does multi-sampling, which we'll have to do at some point. Width over height is the aspect usually. Okay, thank you people who know. I'm sorry, this is a real terrible view into my world. So here it's using random noise generating because these images, when you're doing path tracing in particular, and I realise I never explained the difference between a ray tracer and a path tracer. We'll do that maybe another time, otherwise we'll run out of time here. It's doing multi-sampling. It's very noisy. That's what I was getting at with path tracing versus ray tracing. So when we get to do path tracing, we'll do more sampling and we'll do random jittering and all that kind of stuff, which is going on here. Let's see if we can squint our eyes and see what's going on. We've got, so we're looping in small point for all y's, for all x's, for all samples. Y for all samples x. So we're doing sub-sampling both in x and y. Gosh, Sx goes from 0 to 2. I see it's actually, it does 2 by 2 sub-sampling, whichever way you do it. And I apparently is h minus y minus 1 times w plus x. So you can see why this is not the best source of this information. I might even crib from a previous project of mine because it might be more readable. Let's have a look. Have I got my... no, I don't. Darn. Okay, we are going to have to... This is using GitHub as your own reference. Path tracer, I think it is what it's called. In fact, if I can just remember that, that's just what it's called. I don't have to go to the URL. Git clone that. No. Git at github.com. I remember how to use this. There we go. Okay, so we've got a path tracer here. It's written in Rust. Ow! Cat. What have I got going on here? Lib. No, that's just some other stuff. I don't actually have Rust installed on this laptop at the moment. Scene.rs. Where's the actual main function? Oh, I think it's in bin. Source bin. Path tracer.rs. Let's review that and we get some, at least some syntax highlighting. Okay. So this is almost a literal translation of the small point code. Yeah, yes, Luca, it's more than that. Path tracing is absolutely dreadful. And so I suppose I should explain it. So ray tracing is where you fire a ray down every camera cell and you sort of record what it hits, and then maybe optionally you bounce it around a few times, and then at some point at the end of that, you look to see if there are lights available, and you sort of fire a ray special off to lights. And lights are very special, different things in the scene. They aren't like physical things. And the problem with that is it lacks global illumination properties. So like if you have a bright light and that bright light shines on a surface that isn't a light but is bright itself, like a bright white, like if I were to have a bright flashlight up here, you would expect that the radiance of this surface itself would also act a bit like a light. But because in ray tracing, and I'm sure people will write in and tell me that I've got this wrong, this is my very hand-wavy explanation of this, because in ray tracing, the lighting part, where you determine how much light is falling on a particular point in the graph, is in the scene, is sampled based on these lights. You have to kind of special case lighting. So that's ray tracing. For path tracing, you fire rays into the scene and you just fire. They just scatter around randomly, and they become multiple when you get like reflective or refractive, just like you do with ray tracing. And then you just keep going until they happen upon something that is bright, or until they've just hit enough times in the scene. So that means that for the vast majority of rays that you're firing in the scene, they hit a surface, which bounce onto another surface, which bounce onto another surface. You get to like 20 bounces, and you're like, it never hit anything that had any light falling on it, so I guess we'll stop. And you end up with black. So you have to do it many times until eventually you bounce off this, which bounces off that, which bounces off that, which happens to land on a light bulb. And you're like, oh, this whole path is super bright. And you propagate the light back through that path depending on the relative angles of everything. And so it's pretty cool, and it accounts for all of the things that I was talking about. So here, for example, my camera ray might hit this paper, and it would look at the normal of the paper, and it would pick a random direction scaled by how likely it was that the light could bounce in that direction, and it would bounce off, and it went out the window like behind you. Then it would go, oh, everything's bright because I hit the sun eventually, or I hit the sky, which is a bright color. But you have to bounce a ton of rays around, and oftentimes there's a sad outcome of no light is found. So most of the work in path tracing is done to, like, once you've found some cool light paths, is exploring those light paths to see how many other samples that are viable, that make sense, that you can get without like biasing it towards the lights too much. It's pretty cool anyway. It's fun, and most of modern day, at least as I understand it, most modern day renderers like Pixar's RenderMan and things like that now use something like path tracing. It's considered the gold standard because in very few lines but billions upon billions of samples, you can get something which is just provably right. It's right. And then anything else you do after that is an optimization. Okay, that's the worst description ever of path tracing, but hopefully we'll get somewhere here. Okay, what are we doing here? Oh, you see, look, this is more like it. Somebody, previous me, decided that this was a much more straightforward way of writing this code. So I have a direction here, and I have a camera position. This is looking familiar. Camera X and camera Y. Oh, that's cleverer. That's smarter. So rather than doing everything in terms of what am I talking about? Oh, crikey. And instead of doing everything purely in terms of like a field of view, I'm creating a camera coordinate space where the direction is like my finger. I'm deriving an X value by just defining it, but its length is depending on how wide the screen image is, I think. That's what that 0.5135 would be, is my guess. Over height, so that's the aspect ratio is hiding in there, and then we do a cross product to get another vector. So now I have three vectors. I've got a vector which points in the X direction in world space of the camera. We've got by definition the camera direction, that's the way I'm looking down, and then the other one is just the remaining direction. Okay, that makes some sense. Now when we sample these things, we are going from X0 to X, samples here, and here's the horrific 1/2/2. Okay, that's the same as my adding 1 afterwards and dividing by 2, isn't it? Or is it? All right. Well, we'll have a think about that. But I can certainly get my camera X and camera Y in, and that sort of makes some sense over here. So let's get rid of this field of view for now. No, I'm keeping the 0.5135. What the heck is that? Let's get... Oh, sorry. Everything is really reacting slowly to me right now. Let's get a new terminal up. Let's do a new tab. Come on. Come on, computer. There we are. Python 0.5135. Is that cosine of like 60? Oh, import math.cos 60 sine tan. One of these is the right one. No. Tan 0.32. Math.atan 0.5135. Maybe I meant that. Maybe I meant that. I'll have to come back to this once I've had a chance to reread my I've got a book called, what's it called? Physical based rendering, I think, is the one that I first read of all this stuff. I think I've got it somewhere anyway. All right, I'm keeping that there, and I'm just gonna call this X field of it, and I'm gonna I currently call it 0.5135. It's only because it matches the other. And I'm going to put a to-do, work this out. Got all those code comments, yeah. One does not necessarily need comments if one uses appropriately named variables. Sadly, one has not used appropriate names here. I mean, some of them are. If this 0.5135 had been given a name, I would let myself off the hook there. But oftentimes, if this just said, you know, hey, I'm multiplying width by 0.515, that doesn't help anybody. But nevertheless, so we're going to have campos, camdir, and we're going to actually define those after all those other bits and pieces. We're going to say auto cam x equals, now come on, you go over there, and then I'm going to shrink this to this size, get rid of these two, close group. Alright, now we can see all the codes. So camx, in this instance, we can see some sort of hard-coded nonsense going on here, where we're using this convec3 cam x, and it's just going to be x field of view, comma naught, comma naught. See, that's deeply suspicious, isn't it? Divided by height there. Ugh. That's just dreadful. Const auto cam y equals, and we're just going to do cam x dot cross camdir dot normalized. Oh, you can tell that I previously spelt it the American way, and today I've decided to spell it the British way. Times, and then we're going to say x field of view. Now that's clearly not the right value either to do. That's just not right. There's something that's not right about all of this stuff here. But I really, really, really want to get a picture. And there's so many other things going on in here that I'm going to come back when I'm not like having to explain my every move to you fine people, and we'll work it out from there. Okay. So we now can come back down here, and this XX and YY can be, these are effectively a value between 0 and 1. Maybe, yeah. Maybe I did not make a good choice. So we need a dir x, dir y. And we're actually doing like a manual cross product in there. That's terrible. Oh, no, it isn't. Sorry. I forgot what I was talking about there. Maybe, you know, that doesn't look right to me now I think about it. But we're going to just get something down. Dir x equals. So let's just auto this stuff for now, and I'm going to call it the same for now, and we're going to then think about what all these things are. So x is f64 over width. So that's what we've just done, minus 0.5. So this actually goes from minus 0.5 to plus 0.5, which doesn't sound right to me. Right? So xx is what dir x is already, except that in my implementation here, it's clearly not running from minus 1 to plus 1. And we've got this sort of divide by 2 nonsense going on over here, which I don't like either. And are we actually using that? Sub x, sub y, sub x plus that, sub y. Height minus y minus 1 over height. So that's, oh, I see, that's turning it the right way up. That's terrible. I could have just inverted the bloody direction of the y. That's not how this should be done. So we have some amount. So then direction is auto dir equals some amount of camera x, so cam x times xx makes sense, plus cam y times yy. So this is going to pick of our x and y axes of the camera. We're going to be going either between minus 1 and plus 1 of that. So I guess that's just a difference. I could have defined it as 0 to 1 there. So now we've got a ray that's pointing from the origin to a point on the plane of the origin in the direction of x and y, of the camera's x and the camera's y, and then we're going to also add in the direction. So now we've got in the z, which is just fixed. This doesn't seem all that right to me. And then finally we're going to normalize the whole thing here. Yuck. Yuck, that just seems wrong. And there it jitters it with some randomness, but we're not going to do that. So anyway, finally, we ought to have a value that is maybe. Yeah, thank you, Daniel. Thank you for making me feel better, by the way. Maybe this is the right thing. I'm starting to not feel that it is. We'll do some debugging in a second and we'll work out what's going on. So anyway, armed with this direction, we're going to say auto hit equals sphere dot intersect. Oh, we need a ray now, don't we? So we're going to do ray, because I can't think of a better blinking name. And we know that we need a point on the ray, which is going to be campos, and we need a direction, which is going to be dir. Hurrah. And I think it doesn't need to be normalized here, but we'll come back to that. We won't worry about multiple normalizations. So sphere.intersect ray. And you know what I'm going to do? I'm going to start off the simplest way possible. 640 by 48. Sorry, 64 by 48. All right? And I am going to say if hit puts star else puts space. How crap is that? And then at the end of every line I'm going to put a new line. Or put C, I should say, really. Right? So we're going to do Ascii Art here. Where does put C... Does anyone remember what library that's in? That's the IDE does. No. Oh, this needs to be... Oh, it's telling me that it needs to be a character. Because it's put a character, right? Well, I seem to be picking up put C for free. I don't really like that, so I'm going to make sure I include it. Man put C. Stdio.h, of course it is. Where else would it be? So we're going to at least show some nodding direction in C++ land. And we need to give it a stream. Yes. Yes, we do. Stood out. Is it shoutcap stood out? I think it probably needs to be stood out. File no. I think it is just stood out, right? Yeah. All right, in code that will horrify all of you, let's see what happens when I run this. Oh, first of all, it's going to error because we didn't use Y field of view. So I'm going to get rid of that. This is hardly a good example. Okay, and then we're going to say passing const vec3 as this. Oh, interesting. Interesting, but it's not marked const. We found a bug! Hooray! Even the worst code can bring out, you know, using your code can bring out this stuff. So this is because I don't have a very good test for cross products, it would seem. Do I test cross products at all in vec3 tests? Cross product. I do there. Vec3 dot cross that. Isn't that interesting? Yeah, it did. I'm surprised that that worked because these, I guess they are R values, and so it can take a const ref to it. I don't know. Whatever it is, I'm surprised that those tests pass if we don't actually have the marked const in here. But I mean, I'm going to fix that, and I'm sort of like chalk one up to really test should have ticked this first. There will be graphics eventually, Pantufel. All right, Ray is private within this context. Of course, it's because I defined it that way. So I've got Ray, the Ray constructor, because it is. So this is another sort of like point of my, at least the way that I think about the world. If there is a constructor that clearly and obviously there is only one way of writing it, then I just write the constructor. But I like to name my constructors if these things are not trivial. So for example, if Ray took two vec3s, and it would be very easy for you to not remember that one's a position and the other one's a direction, or vice versa. Now I could make them different types, which has a certain amount of what's it called, advantage to it, but I haven't done because it's just too convenient. I might come back and think about that, you know, vec versus dir, because there's a certain appeal to knowing that you're dealing with a normalized value by type. Like the type system has said, no, this absolutely could not have been constructed unless it was actually a normalized value. So that kind of makes sense. So someone's just asked what the const expr and no accept. That's kind of the experiment, actually. They are there to see whether or not they can help. To answer the question more specifically, constexpr allows says that this function in principle can be ran and provided all of its arguments are derivable by the compiler, it can be run at compile time. Of course, all functions are like that. So there's definitely some questionableness about whether the constexpr is useful. And the no except says that I'm promising that this does not throw any exceptions, and the compiler will tell me if I call anything that could cause throw an exception to some extent. If an exception is actually thrown, it will actually call terminate. The application will just die rather than having to do anything. And that allows upstream code to sort of rely on that. And again, it's of questionable use, and I maybe will take it out. And half of this is my experiment of writing it, and I'm going to see whether or not that actually does make a difference to the quality of the code generating afterwards. So I will probably end up making these things like, you know, some horrible constexpr like that, so that I can hash define them in and out, and then go, oh, it does work, or no, it doesn't work. Or sorry, rather, it runs better with constexpr or without without constexpr. So I'm going to do this from ray and from pos and dir, and we're going to call this a point. Everything else is called a point from origin and dir, as that is what we're calling these things. So this is going to be origin, and this is going to be direction. And I should probably assert here, there's a to-do about assertions here, because I haven't yet really formed my opinion about whether or not they should be, how to do with assertions. And I maybe end up using some of the C++20 contract-based stuff, which would be cool. Dir is normal. So here, this is just basically naming the constructor that I already have written above. Origin, dir. And again, this position here should probably be called origin, right? Consistency. And this should be direction, because that's what I'm calling it everywhere else, even though it's longer. Did I overspill? No, it just fit. The to-do can stay that way. Oh, direction. Okay, so now when I construct this ray, I'm just going to do auto ray equals ray colon. I like the idea of direction being a type now, you know. Gosh, this is confusing to me. From origin and direction is what I'm going to call this. From origin and direction. Therefore, it's clear. It also means that if I have the direction as an actual type, then obviously these kinds of operations, I can just use an unnamed ray constructor, and there's no ambiguity, because it'll just take, hey, if I'm constructed from a vector and a normal, then what else could it be? But if I'm constructed from two vectors, then I know it's two positions in space. Okay, I like that. It's going to be more work, though. Let's see what the compiler says now. I'm sure as heck we're just going to have an empty string, right? Const aspect ratio. Oh. Yes. All right, so far we've actually got a square. Oh, my word! No one is more surprised than me that actually did something. Can you see? We made a picture of a sphere. It's a circle. It's made out of stars, but it bloody worked. These dots here, by the way, I've got highlight trailing white space turned on, so that's what's going on here. How amazing and extraordinary. Flabbergasted. So let's try and fix this up a little bit, because there is just a lot of things in here that make me feel unwell. But before I do that, I am going to grab another glass of water, or I might treat myself to a Diet Coke. So AFK 2 mins. And the cat's got its claws in my foot. Back in 1 second. It's important to have treats, right? Oh, I don't have any milk, but I have a can of Diet Coke. Oh, I think we can live without that. Okay, let's take stock. So back to the original intention, is I'm doing this as an exploratory work to see whether there is enough meat on the bones of a talk that would be called something like path tracing done 3 ways, like as an homage to like the way that, posh restaurant people will do a particular food in 3 different ways and show you, how it could look. So this is definitely heading towards a way of doing something. But I was hoping that things like the math library would be shared amongst the 3 different ways. But the way that the way that I'm looking at this now, the type, using the type seems like a really good thing to do. And I'm wondering if there are just too many dimensions here, because if I were to do everything in an OO style, I could also choose to do things with strong types or without strong types, and for the math library. So I'm really conflicted now. I don't think I've gotten a clear read on whether or not there is either too much work in doing it in multiple ways or not enough work. If I were to take certain things as read, like if I always did the math library in one particular way, that's one dimension. If I were to use object-oriented design for the scene graph, which we haven't even got to yet, our scene graph currently is a sphere on the stack, then that's another way. So I think I still need to ruminate on this more, but I only have a few more days to get this to the point where I feel confident enough to make a proposal for a talk. I mean, it's certainly interesting to me, but that's not necessarily enough. And also I'm wary of the amount of work that it would be to do this large scale. If I actually made this a full renderer, it will be soon enough, would that be too much? So I'd be interested in what you think. But anyway, more importantly, we have a sphere on screen, and at the moment it'll be an actual sphere, or it may it'll be an actual sphere. It's going to be squished in, I think, because I've used the X field of view for both X and Y. So I would like to zoom out a bit so that we don't see... let's push the sphere back in space. That's the easiest thing to do. Should we just make the sphere further away? Let's make the sphere further away and see if that takes effect in the way that we'd like. Hooray! It does, and that's cool. So rather than it being Ascii Art, let's turn it into an actual picture, and then we can look at things like aspect ratios and try and work those out. And what's the time? It's 1:30. I've been going for an hour and a half now. I'll try and cap this at 2 hours total, so another 20 odd minutes, 24 minutes, just to sort of see where I am. And then I'd be really interested in any feedback you might have about what has been interesting about this process, about just the guts of it. And again, this is me. So far, this is all supposedly just the scaffolding, the framework, and then the interesting bit is yet to come, where I rewrite the scene graph and load it in different ways. But and of course, we're not actually doing any path tracing at the moment. We're just doing intersection testing, which is very, very different again. And there's a whole bunch of work that comes off that. And yeah, I'm wondering if this is the right thing. So much of what makes a path tracer interesting is just basically this bit here. This will be scene.intersect, right? And it'll have a ray. And then the bit's either the bit that finds the initial ray that comes from the camera out to the point in the direction of that part of the camera is going to be the same pretty much however you do it. The bit that that determines, having found an intersection, where the next ray should go off to, or whether indeed the ray should fork into 2, which is done a very dodgy way, is going to be the same. So really what I'm talking about doing, varying in this talk, is the scene graph. And so I can only really think of 2 ways of doing a scene graph. Now, well, there's 3 ways if you count hard coding the scene graph like I'm doing here. So one thing we could do is we could have 3 ways. We could have one that uses OO and loads from a file, one that uses studvariant and visits for each of the different type of thing, which is going to bring up its own problems because studvariant at least can't have self-references, so you couldn't have X within X within X, which I think a decent scene graph would probably have. You want to have a hierarchy of sphere bounding boxes and things like that. And then you could have hard-coded, I literally type out the scene like this, like it is in the, wherever I left the Rust code. Oh, it's in here still, right? Here the scene graph is that. It's hard-coded into the code. Now, could write it that way, and that would be an interesting experiment in how much the compiler would be able to optimize. And certainly if I could have the same scene written three ways, one like dynamically done using OO, one dynamically done using variant, and then one not at all dynamic, you just compile your scene and link it against the library as a third way. It would be interesting to compare the performance of those three ways. But that's essentially just the intersection code and the way that the scene is stored. So, I know, sorry, I'm thinking out loud here and I'm not programming. I'm using you as a sounding board, so I appreciate what you're thinking there. But let's get a graphic out now. Well, the way that Small Point does this is it uses this dreadful PPM format, which we're going to totally and utterly steal, sorry, use my colloquialisms right now. So, despite all of the horrificness of FileStar, I am going to use this as well. I'm going to get rid of that comment because it's pointless. We're going to put some command line parsing with Clara in a second. And write an image to PPM file is not actually what we're going to do. We're going to say, we're just going to get rid of that because it's pointless. And because it hurts me too much, I'm going to put F close down here. Or I should use a std unique point. Well, F to do unique pointer thing here. We'll actually close it out. That needs to live up there. So printing it out, width and height become width and height. Width and height. This is all to stop myself from actually having to store every single one of these, because I do actually just want to sorry, I am just gonna jam while this happens in my head, and you can laugh at me afterwards. Let's minimize you. We get rid of that on the left hand side. Now I can actually see. And then we need to do that. So this is a dreadful thing we're going to call fprintf on every single one of these things here. So this is going to be color. Let's just .x. Color.z, and we're going to close that off there. Should probably check the return value, but who honestly checks the return value of fprintf? I do in production code, I'll be honest with you, because it's bitten me enough times. We're going to steal that. My dishwasher has just told me that everything is clean, which is nice of it. I think we've got some, there are some nicer ones. Oh, I see. That's quite kind of neat, isn't it? All right, we don't want that. We don't want that. This definitely needs to be tidied up, because I think there is now a what's it called? A thing, you know? A thing. Format. Yay. See, again, look here. This is horrible. Right? It's going to keep putting that on the same line. Grr. All right, I'm going to get rid of my worries about that right now. To do unique pointer color.z. Did you mean to call it with no arguments? I did not mean to call it with no arguments. What are you talking about? Oh, because there's... Yeah, right. Yes, I did. You're right, IDE. That's exactly what I meant. Thank you. See? Clever. Okay, so this is calling pow, which comes from CMath, which we don't actually have here. CMath. We've got clamp, and clamp does that. Now, I think there's going to be a much smarter way of doing that clamp function. Why are you complaining? Casting incorrect using L round. Casting to integer. What? Really? Sure. All right, Clang Tidy. Seeing as you're so smart. No. Arrgh. What? Actually, what was that error? Oh, I'm ignoring it for now. We'll come back to it. I usually, if there's like a little warning like that, it causes my spider sense to tingle too much. So we're going to run this now. We're no longer going to see a pretty output, but we are going to have a ppm in that directory now. So let's go to dev pt3 ways, and it'll be in the cmake build debug directory. We hope. We hope? Where did that go? This is where you don't check things like the return value of image.ppm. What the heck directory do you run in? Let's go and find out. pt3 ways, edit configurations. And your working directory is empty, which I think means should be the root of the project, but I could be wrong. Or is it where the binary lives? It's where the binary lives, at least where it is right now. Okay, so Let's see if our beautiful image is now a not round sphere, is my expectation here. Not round circle. I should probably not use GIMP for this. It's a bit overkill, right? It is, exactly as anticipated, a not round circle because of the aspect ratios and my knowledge that that's just not set up right. Does EOG understand that file? It does. Okay, cool. We have a much faster to start up like viewer. Excellent. And we can obviously pick up things like libping and stuff and actually save ping files. Actually, I wonder what we got in Conan. Oh, I'm going to get sidetracked, aren't I? Let's do Conan search minus R Conan search or PNG. See if there's anything that immediately just sticks out in Conan. No Mac packages mentioning the PNG file format. The PNG pattern. So there's no package for this. All right. Excuse me. Oh, excuse me. I always get hiccups from cold Coke. Conan Center, PNG image. Oh, this is going to be a bad thing. Okay, right. Not going to look any more on that. It would have been a golden moment if it had gone, oh yeah, there's just libpng. Go pick up libpng, and then I could just bring it into my project and we could run with it and we could output PNGs and there'd be much smiling and laughing. Okay, casting to integer leaves L round instead. If I just use L round, does it just work? Why you complain? Single but two. Oh, right, it means here, doesn't it? L round of that as an int. Sure. Okay, so we've got our image out. Let's bring back our aspect ratio. And one of these needs to be times aspect ratio. And I think it's going to be this way round. There was something to be said for the stars, wasn't there? It was very immediate. Yeah, okay, so that's, for some definition of better, that's better. So this is definitely the Y field of view, so why don't we rename this as Y field of view? Yeah, no, just code usages, because I know that I already have something called Y field of view. And we now know that we can do const auto X field of view equals Y field of view times aspect ratio. And then this thing just becomes X field of view. So we have a direction, so X field of view. All right then. So this is actually a crappy way, a not very good way, I should say, of doing it. So really we should just start with normalized vectors and then scale them afterwards. That's really what we should do here. I don't like the fact that this has been done this way, so we're going to change it. So down here where we've got this camx times xx, this times xx is now also going to be times x field of view, which is not the right value yet, but we'll come back to it. And then this is cam_y times yy times y field of view plus camdare dot normalized. I'm going to have to line break there and see what happens with everything. Okay, so this just becomes 0, 1, 0, and then this just becomes the cross product. So I can get rid of the to do there. And I mean, not sure this is FOV because it may not be. Oh, did that auto reload? You know what? I think EOG auto reloaded. Let's find out. I'm going to change this to magenta. Oh, isn't that lovely? Oh, that's beautiful. EOG, you are my new favourite program now. I'm going to make this always on top, and you can live sort of like that, and I can move you up there. And now we always have like a, hey, this is the last picture I drew. Oh, splendid. What if we were to make this 640 by 480? Right, we're still in debug mode for what it's worth, so it's going to take absolutely ages. What isn't obvious here is this 2int is also doing something called gamma correction. That's what it's called, gamma correction. It's where it's effectively taking linear outputs from the rendering process and turning it into a more physically accurate representation, or the other way around. I forget. I've read this huge treatise on gamma correction, which was so awesome, and it's gone in one eye and out the other. And I've obviously misspelled my comment here. Not sure. Okay, so 2int is not the right name for this. This is going to be... so those are component to int. So that's like a component of the red, the green, and the blue. Splendid. And you'll find no other... You don't need to search very far. And line breaking should happen there. Thank you. I really don't want it to happen there. Component to int. Now clamp, we know there should... I think there's a new thing in the standard for this. Let's look for stood clamp, if I can remember where I've left my... somewhere. Thank you, Victor. Somewhere stood clamp, and we hopefully don't get any transmitted disease thing. Stood clamp, okay. If low, that's high. So I always used to write this with the x value in the middle. I like to have low, my variable, high, which I realise is totally weird and nobody likes, but it was just something I did as a kid. 20 years ago, when I was writing renderers for the Sega Dreamcast. That's how I wrote my clamp function, but it looks like we have the value and then the low and then the high. Excellent. So let's use stood clamp there. So we can get rid of that. And this becomes stood clamp of x, 0.0, 1.0. I don't like all of these things are mixing this stuff, this style. This is all coming from which clamp? Yes, from... Well, this is unfortunately a bit of a fail for the IDE, isn't it? Did you mean function stood clamp from regex? No, I really didn't. I don't think I'd ever use a stood regex. Not because of... Not since HANA has such an amazing compile time regular expression system. Let's go and get it from algorithm directly. That's where it really lives. Come on, include algorithm. Drum roll. See, why is that not in numeric? Some things are in algorithm, some things are in numeric. Oh, I don't like that. That's a clang tidyism, isn't it? I prefer my IDE to tell me this rather than it being explicit in the code. That's what I do. Okay, brilliant. So we've slightly improved this. Let's do this to do of unique pointer, because opening a file like this is pretty miserable and manky. So a bit of C++y tradecraft, right? So let's go and get memory all alone with my memory. Then have oh, come on, unique pointer of file. So it's a pointer to a file, and then it's going to be of type decal type of f close. This is the function that's going to close it, f. Ugh. And it's going to be that. And I think I need to pass in f close there. And I don't know why I put 2 colons there, because we're in trouble if it didn't work over here. It won't work over there. So we can get rid of that. And does that actually work? I don't think that's going to work. Surely that's not going to work. Yes. Required from, of course, the obvious, the C++ is so beautiful. Yeah, alright, thank you, Luca. Yeah, it's just not obvious. None of these things are obvious. Yeah, so this was the thing I was expecting. This is the f.get now. And f.get here as well. And this really is the world's most miserable file format. We shouldn't be doing it this way. Right, what are you complaining about? In instantiation of stood head base of this, of required from this other thing, invalidly declared function type. Oh, I know why. It's decal type of this pointer, obviously, because I need to give it a function pointer. Sometimes I just make a whole type for it. There we go. It's obvious, right? C++, everybody. It's really straightforward and simple. Okay, so anyway, we've got that, and I imagine that'll go soon enough because we'll end up not using the a ppm image file format because it's frankly rubbish, as you can see. But you know, this component to int thing is still going to be useful and valuable to us. I don't like this namespace thing. I wish you would go away, and I should go and find out how to do that. The x field of view, y field of view. So there's an interesting thing going on here, actually. Let's just think about what's going on in this camx times xx times x field of view. What we've got here is a vector multiply with a scalar times another scalar. Now, a vector multiply with a scalar is x times equals scalar, y times equals scalar, z square times equals scalar. So there's three multipliers that get hidden away in this camx times xx, right? Then the result of that is a three-dimensional vector. And then we'll multiply it with x field of view. So we're going to do yet another 3 by 3 multiplication. It's not at all obvious that if I were to put parentheses around these two things here, that would be a faster operation. But it definitely would be, right? We'd take two scalar values, you know, 0.3 and 0.5135, whatever the heck that is, multiply them together once, and then multiply the result of that with a vector. So that's got me thinking. I wonder if there's something clever I should do here. I mean, certainly I can add the times x field of view in the scalar domain up here, but there's no way that the compiler can see through that because multiplication in floating point domain is not commutative. A times B times C in general is not the same as C times B times A, or A times B times C is not equal to A times B times C. Now, I know that it's okay here because I'm the programmer and I get to choose that. I know that multiplying those two things together is exactly equivalent, and at least for all the values that are going to be fed into it. So yeah, Luca, so I've just looked over, Luca, and you've asked the question. Yeah, it would be lovely if the compiler did do that optimization for me, but it is unable to. And I wonder, if there's a popular website that we can use to determine what's going on. So you're going to get to see how my own site... Oh, I don't need this on top anymore, do I? How are we doing? 10 minutes I've got. Oh, thank you, Sebastian. Thank you. I will do that forthwith. So let me bung that in. So we've just copy-pasted the whole Vec3 class into Compiler Explorer. And you can see the remains of all the nonsense I end up doing. Let's turn all these things back on again. In fact, I am going to reset this more. Reset code and new UI layout. Please wait. And we're going to paste that back in again. Excellent. 03. No assembly generated because we haven't asked it to, right? It's unsurprising. Hopefully that's not surprising to anybody that a class file does not usually generate any assembly code. It's only when you use it, the compiler works out which functions that actually it needs to generate code for. So then we've got some vector times two scalars here. I am going to do something like auto test. Oh, let's do vec3. Vec3 test. And this is going to take vec3, const vec3 and a, double b, double c. And if I could type, and I'm just going to do return a times b times c. And we'll come back to that. Interesting, eh? So this is test one. Excuse me. And then only write operations for with scalars on the right. Yeah, but I don't know if that works because I think multiplication is left associative. So you'd have to always write the scalars on the left. So then it would always be scalar times scalar times scalar times vector. So let's put this one as test 2. And if I put just the parentheses around here, now we can see that unfortunately it's clever enough. It looks like it's generating the same, no, not quite the same code. If only there were a feature that we could use to determine which is the right way of doing this. So let's do that. So I am going to go if def AAA that else end if, and there are ways to do this with two different code views, but I can't be naff to do copy paste all the codes. All right, so we now, if we've got AAA defined, we're going to do it one way. Actually, what do we call it? This is if not defined, scalars first. Scalars first. Then we do it that way. And then I'm going to make a new compiler pane by cloning the compiler and dragging it down there. And then this chap will have D scalars first. Hurrah! Okay, so we do have a noticeable difference in the code output. And if I add a diff view, we can see what they are. Okay, and maximize. These are buttons you probably don't know. Okay. So it's the same number of instructions here, which I know I've said many, many times before. So someone's just asked why I'm not using the C-Line extension for Compiler Explorer. I don't think it's got support for the version of C-Line that I currently have installed. I've got the latest version. I always go with the latest version of C-Line. And I haven't used it all that much, I'll be honest with you. It's awesome to have it, but I haven't really got into the habit of using it, mainly because I'm usually on the EAP, the beta version of C-Line, and very rarely does it have support for that, which is unfortunate because it's a great idea. So I know I've said many times before you shouldn't count the instructions, but let's just count the multiplies. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. So there are 4 multiplies in both cases. So nothing actually has been saved here. It does look like the code's been shuffled around in a slightly different way, but ultimately the compiler has been able to take advantage. And now presumably this is because it can do those parallel multiplies. It's clever enough to have vectorized it. So the parallel multiply is pretty much the same. So let's just check that hypothesis. We should see parallels on one side and scalars, more parallels than scalar multiplies. And that's the P here. So we've got scalar multiply, parallel multiply, parallel, hang on. Scalar, parallel, scalar, parallel. Over here we've got SD, what is that one? It's just not parallel. Oh, it's scalar, yes, parallel, scalar. All right, I'm talking rubbish. It's obviously been able to do something much cleverer than I know. F no tree vectorizer. Let's turn that off. I'd like to try and see if I'm right on something. What is the thing called? All right, GCC tree vectorize. No tree vectorize is what it should be. No tree vectorize. Hurrah! And obviously we should. So I'm turning off the thing that should allow it to vectorize the, which is totally unfair. Of course, absolutely and utterly unfair. But even with this, it looks the same. Yeah, I totally agree. Pantuful. I'm gonna paste this into the chat for those who want to follow along. You'll have to like minimize or close the window that's up. Scalars all the way. So here we've got 4. Okay. So in this instance, if we do turn off the tree vectorizer, which means it's not able to vectorize those x times equals scalar, y times equals scalar, z times equals scalar, then we do get more instructions. But colour me surprised. That's really nice to know that the optimizer is actually able to do the work that we would hope it would be able to do. So whoever said that, Sebastian, you were saying about the other things. Luca, it actually was being able to. Yes. What has my compiler done for me lately? Again, I mean, I've already got several of these, but this is definitely one of those ones to add to my list for the next time I'm asked to do some work like this. All right, let's close that all down and come back and take stock of where we are, which is that I've been talking for nearly 2 hours. We've got 4 minutes left of the sort of scheduled time that I had. We've got a magenta circle that has been very hard won. I guess we should probably we could do something even nicer here by saying, vec3 color. So that will default construct to black, which is the right color for us here. If hit something with color. We're going to say color, whoops, color equals, and now we're going to get into where the scene graph is, because at this point we need to know what the material at the point where we hit is about. So, I mean, I'm just going to say vec3 material is 101, which is, materials are not just a color, they have a BRDF, there's all sorts of clever things with them. But what we're going to do is we're going to say, we're going to take a dot product with the camera ray, which is not right. None of this stuff is quite right. We're going to go dot with hit normal. So this will tell us how much the camera ray is pointing at the light bouncing directly back. Again, this is just crappiness. Oh, Odin! Thank you, Odin. Yes, I aim to please, and the only thing I would say about your comment is that I think self-evidently one of the best programmers in the world is not true. I am a programmer like anyone else, and we all have a good laugh. And look at that, no viable overloaded. Oh, because I haven't finished writing it yet. So anyway, so the dot product, if the dot product is pointing directly at the sphere, I'm going to say, cool, that should be brighter, right? And obviously that would mean if it's pointing directly at it, we've got 1 in one direction and -1 in the other. So it's going to be negative. So we're going to do something like, I'm just going to square it. There's absolutely no physical explanation for why this is valid. We're just going to say auto nice equals that. And then we're going to do, I should probably have a square. That's a really useful function to be able to have, right? I usually have, back in the dawn of time, I'd have some shout caps square macro, but I'm going to have square of that, which is power of 2. And in fact, the compiler is smart enough because of clever. Let's go. Have I got it around still? Humble, no, just honest. I love how people think that I'm a good programmer. I've written a crappy JavaScript website that everyone uses. That's wonderful. I'm so glad that people use my site, and I use it all the time. And I do like hacking around with low-level stuff, but there's really no evidence anywhere in the world that I'm a good programmer, in C++ specifically. Okay, let's go and just check that this... So double moose, double x, double x, and moose is going to return pow of x, 2, which is what I'm about to write, and I want to make sure that it is actually able to do C stood math. Get rid of that. We can get rid of that. And the code doesn't compile because it's not called C stood math. What's it called? C math. Stood math. What am I thinking? C. Okay, cool. That is clever, right? The compiler knows that this is a defined function by the C runtime, and it knows that it can like vary. So if this is 2.01, it's gonna be a function call. Look at that. It's like, no, that function call. Right, lovely. Write the code you want to see yourself, and then let the compiler figure it out. So I don't have to write a square function. I'm just going to power it with 2, and then we're going to multiply that by mat, which is the material color. And apparently I haven't written. So whoever said about having the function thingamajigs the other way around was probably right. I haven't written the operands the other way around, which is naughty of me. Okay. Let's run it and see if we get... Oh, there we go. You see, that's what we wanted. We went to all the effort of not drawing ASCII stars and spaces and things, and we now have quite a beautiful planet that... that, you know, any one of us would be happy to visit in our favorite space flight simulator. So I think I think this is a good place for me to stop before I go quite bonkers talking to myself. I appreciate everybody's patience. I am really on the fence about whether this is a good idea. It certainly shouldn't be done 3 ways. I don't think. Although... Yeah, I should think about it some more and not like at you. But if anyone has thoughts, it is a ball. No, it's the planet, Luca. I'm going to check this code in its current form. I need to work out what this 0.5135 is. I think it is the tangent of the vector, but I think I may have doubled or halved something along the way with with respect to that horrible Rust code I was copying from. I appreciate everyone's comments. I will go back and fix up a few bits and pieces, and I will probably do some more of this later in the week. My real hope this week, though, is to get more of the execution support into Compiler Explorer, the thing that you actually care about, I'm sure, more. So I appreciate you being with me. I'm going to stop talking now, and I hope you have a lovely rest of your day, whatever time zone you're in. And if you want to see more things like this, then check me out on Twitter or subscribe, and then you get the notification when I go live. So thank you all very much. And now I'll get the awkward moment where I try and close down the streaming, and you get to see me staring at my computer for a bit while I find the right buttons and find the no, yes, really stop streaming. You see this bit? Where is the button? Do I just stop streaming? I think I just stop streaming in my app, and then it all just works out. So I will do that now. Bye for now, everybody.